Hello kids, let's start with the prime factorization of product of two numbers today. I hope that you have revised all the things for co-prime numbers, the prime factorization, which we have done in our last. So let's begin with the prime factorization of a product of two numbers. So what is given here is, when we find the prime factorization of a number, we must write it as a product of two factors. Example, 72 is written as 12 and 6, and then we find the prime factorization of each of these factors, that is 12 and 6. And now you can say that what the prime factorization of 72 is. So what they are saying is, we can break it into large factors and then we can drill it down to the lower factors. We can also write this as 2 into 2 into 3 into 3. That is, we can also change their places, what we have understood by the commutative property. Now multiply them and check that you get 72 back. So this will happen if we multiply all these factors in which are mentioned in this position, and if we also multiply these factors which are where the position are shuffled. In both the cases the product will be same, 72. Now observe how many times each prime factors occur in the factorization of 72. So if we see here, 2 is coming 3 times and 3 is coming, this 3 is coming 2 times, right? Compare it with how many times it occurs in the factorizations of 12 and 6 put together. So what they are saying is that if we take the factorization of 12, which will and 6, so let's find their factors. This will give us 2 and 3, and this will give us 2 and 2 and 3. And if we put together these factors, that is, if we combine them, so I can write this as these factors and these factors. So here also we have 2 3 times, okay, and 3 2 times, like what we have written here. So that means that it doesn't matter that how we are writing these numbers, these factors, their multiplication will always give us the same product, the same number whose factors are these numbers. Now let us do the figure it out of this exercise. So I will start from here. What we need to do here is, we have to find the prime factorization of the following numbers. So these are many numbers given to us. Let us pick up 4 numbers and try to find out their prime factorization. So first 2 numbers and last 2 numbers I'm doing, kids, and rest you have to do this on your own. This is homework for you. These are very easy. First is 64. So let's try to break it. I can write 64 as 8 multiplied by 8, right? And now I can break this 8 into further lower prime factors. So 8 will give me 2 into 2 into 2, right? 2 multiplied by 2 multiplied by 2 will give me 8, and here also 2 multiplied by 2 multiplied by 2 will give me 8. And if I combine this, I can write 64 as 1, 2, 3, 4, 5 and 6. 6 times 2 will give me 64. So this is the factors of 64. So the prime factor here is 2 only. Now B, I'm taking 104. So how can I write 104? I can write this as 2 multiplied by 52. And now I can break this 52 into further lower factors. So how can I do this? I can break this 52 into 2 and 26. This 2 I cannot break further. I can break this 26 as 2 and 13, right? And if you see here, this is the lowest prime number. It cannot go beyond it, and 13 is also a prime number. So again, we cannot drill it down further. So what are the factors which we have here is this 2, okay, and then this 2, because I'm not breaking it, I'm taking this 2, and the last 2 factor, this 2 and this 13. And if you will multiply all this, you will get 104. So all these are the factors of 104 here. Easy. What we have done, I have taken 2 as one of the factors and 52 as the another one. Then I am breaking 52 into the lower factors till I get the lowest prime numbers here. Okay. After which I cannot break it further. Next, I am taking 1, 3, 3, 1. So for this we have 11, and with 11 the other number we have here is, again we have 11 here, and again we have 11 here. Okay, so if we multiply 11 three times, we will get 1331. So kids, we know 11 is a prime number and we cannot break it further. So these are the factors of 1331. Now last we have 1000. 1000. How can I break 1000? I can do like this. I can write 1000 as 10 multiplied by 10 multiplied by 10, right? And then I can break it further. This will give me 2 and 5, 2 and 5, 2 and 5. So that means the factors are, I'll combine all this, 2 multiplied by 5 multiplied by 2 multiplied by 5 multiplied by 2 multiplied by 5. So all these are factors, and if I want to shuffle them, as in if I want to change their position, I can also put them like this: 2 multiplied by 2 multiplied by 2 and 5 multiplied by 5 multiplied by 5. Okay, so if you take product of these or product of these, the answer will be 1000 only. This is the commutative property which we have done. Okay, so rest of the questions, kids, you have to do it yourself. And now let's move to the second question. The prime factorization of a number has 1 2. Okay, I'm writing it simultaneously. Answer 2. It has 1 time 2, 2 threes, that is 2 times 3 we have to write, and 111 and 11, and we have to find the number. So these are the prime factorization, that is the lowest form. That means we are not missing on any number. So what we have to do is we can multiply it and we'll get the number. So number here will be 3 3 3 into 2, 3 into 3 is 9 to 18. Now what we have to do, multiply 18 with 11, which will give us 198. So this is a number. Okay. Next, find the 3 prime numbers less than 30 whose product is 1955. Okay. So we want 3 prime numbers. Okay, this and this and this, and their product should be 1955, and these 3 numbers should be less than 30. Prime numbers should be less than 30. This is also given to us. So kids, if you see this number, we can very well identify here that this number is divisible by 5. That means 5 will be one of its factor. So I can straight away write 5 as one of the factor. So we have 5 here, and after using the 5, we are again left with the number. So let's see if I divide 1955 with 5, what I'll get. Okay, so I'm doing it here for you. Quickly we'll do. This is 5, 3, 15, 45, 9 and 1. Okay, this will give me 1. So we have 391 as the product. So now what I have to do is I have to find out the factors of 391. So kids, the factors of 391, it's very easy to find out since we have to find 2 numbers only, and we know that if we multiply the 2 numbers, the product here, it should give me 1 at the unit place. Okay, 1 at the unit place. So what are the possible values I can take? I can take less than 30, right? I can take 7, I can take 17, I can take 27, and here I can take 3, I can take 13 and I can take 23, because when we will multiply 7 with 3, then only we will get 1 at the unit place. Now the numbers should be prime. So first of all, we will remove the numbers which are not prime. 27 is not a prime number, so we cannot take it. Okay, so we are left with all these numbers. If I multiply 7 with 3, this combination is not true because it will give me 21, which is not 391. Again, if we will multiply these, I'll get 91. This combination is also not possible. Now, if I will multiply 7 with 23, it will give me, let's see, 7, 3, 21. It will give me 161. Again, this is not true. So 7 I am removing. This is not possible. Now 17 multiplied by 3 will give me 51, which is also not true. So that means I am also removing 3. Why? Because it is not giving me number on multiplying with 7 and 17 both. So now I have two combinations, 17 and 13 and 17 and 23. So kids, let's try to multiply 17 and 13 and see what we will get. Okay. So this is 17 into 3, 51. This is 17. 1, 7 plus 5 is 12 and 2, 21. This is also not true. So I'm also removing 13 now. Now we have the last number, that is 17 multiplied by 23. So let's do this. So we'll get 7, 3, 21, 7, 2, 14, 17 and 23 here. 1, 23, yes, 17 and 23. So I'll get 1, 3 and 1, 2 is 2, 1, 401 here. Okay. So kids, if we'll do this is 7, 3, 21, 7, 2, 14, 16, 6 will come here, sorry. So we will get 63921 as the answer, which is given to us here. So what I can write here is the other two factors are 23 and 7. So now we know how we have find it out. What we have done here is we have seen that what will come at the unit place, and we have find out all the possible multiples which on multiplying will give me 1 at unit place. Then we have removed the first, the non-prime numbers, because we need the prime numbers here. And then we have seen that how on multiplying these numbers we will get 391. So the numbers which we want here are 5, 23 and 7. These are the three numbers. Now, next we have here is find the prime factorization of these numbers without multiplying first. That means we don't have to find their product. We have to multiply and get their answer. So let's do this. Answer number 4 I'm writing here, and again I'm going to pick just one part of it. This is very easy, and now we know that how we have to do it. So 56 and 25, we have to do their prime factorization. Let's start with 56 first. Okay, so I can write 56 as 7 into 8, and further I can divide this 8 into 7 into 2 into 2 into 2. So for 56, these are the factors. Coming to 25. For 25, we have 5 and 5. Right? So these are the factors of 56 and 25. They do not have anything common in them. Okay? Now, second, B and C part is very easy, kids. You have to pick this yourself. This is a homework for you. Now coming to the last part, last question of this exercise. What is the smallest number whose prime factorization has 3 different prime numbers? So what we need is, we need 3 different prime numbers. 3 different prime numbers. The smallest number whose prime factorization has 3 different prime numbers. So prime factorization has 3 different prime numbers means if we multiply these, we will get the number, because we are talking about the prime factorization. That means the lowest possible factors after which it cannot be drilled down. So we have to find these and we have to multiply this. So let us find out the first 3 prime numbers here. That is 2, 3 and 5, right? Because if we multiply, these are the three different numbers first. These are the prime numbers also, and then we have to find, and these are the smallest prime numbers also. So if these are the smallest prime numbers, their product will also be the smallest number, which we will obtain by multiplying this. So what we have here is, we will get 3 multiplied by 2 is 6, multiplied by 5 is 30. Okay, so I hope this is clear. What we have done, we have taken the three smallest prime numbers, three smallest different prime numbers, because their multiplication will give us the smallest number. Okay, and now in the next we have to find the four numbers. So this is easy. Again, 2 into 3 into 5, and now the next number we will take here is 7. So this we will multiply this, and this multiplication will give us 210. Okay, so this is also done. Now what we have here is using prime factorization to check if the numbers are co-prime. Now we have to use this, and we have to see if the numbers are co-prime or not. Let us again take the example of 52 and 63. How we can check if they are co-prime is, we can use the prime factorization. So what they have done, they have written the factors of 56, they have written the factors of 63 here, and we see that 7 is common in both. 7 is a prime factor of 56 as well as 63. So that means they are not co-prime, yeah, because we have 7 common in them. Now, what about 80 and 63? So the same exercise, kids, we have done earlier, where we have two numbers and we have to find out that if they are co-prime or not. We have written their factors, and except one, we'll see if they have anything common in them. Okay. Now, similar, what about 80 and 63? So here also we have written them, and we see that none of the factors are common. That means they are co-prime. Now, suppose that they have a common factor that is composite. Would this prime factors of this composite common factor appear in the prime factorization of 80 and 63? So yes, if they have anything common, it will come. As we have saw in the discussion above, if 75 was a multiple of 21, then all the prime factors of 21 would also be prime factors of 75. Okay, so kids, now what they are saying here is, I'm taking one example. I'm taking 75 and 21, and I'm writing their prime factors. 71, it is 7 and 3. And for 25, this one we have 3 and 25. Okay, we have three common first of all. So if we have three common first, so they are not co-prime. This thing is done. Now using this, can we identify here that 21, it is written here, we saw in this, if 75 was a multiple of 21, then all the prime factors would be this. Can we see that 75 is a multiple of 21? Or you can also say that using these numbers, using this prime factorization, can we identify that 75 is divisible by 21, or 75 is a multiple of 21? Using this data, using this information which we have find out the factors of 75 and 21, can we infer that 21 is dividing 75 fully, or 75 is a multiple of 21? So kids, if we see here, we do not have this one. I can also break this into 5 into 5. Okay, all the multiples are not same. All the multiples which are present in 75, they are not present in 21. We do not have 5 here, and we do not have 7 here. If all the multiples of 21 are present in 75, in that case it is fully divisible and it is a multiple of 21. Otherwise it is not. Okay, so here we have given another example. 42 is 42 divisible by 12. So what we'll do here, we will write down the factors of 42, and they are 6 and 7, and which we can further divide into 2 into 3 into 7. Okay, so these are the prime factors of 42. And the next number which is given to us is 12. For 12 we have 6 into 2, that is 2 into 3 into 3. Right? So now if you see here, we have 2 here, 2 here, 3 here, 3 here. But this 3 is not present here. Okay, this is not present here. So that means this 12 is not dividing 42 fully. Okay, this 12 is not dividing 42 fully. If one more 3 is present in 42, in that case it would have been divided it fully, but now in this case it is not dividing it fully. But if you observe this, there is one number which can divide both of them fully, and that is the common factor in both, that is 6. If I take 6 here, if I'm taking, let's say, another example, and I'm saying, okay, let's see if 6 is dividing these two or not. The factors of 6 is 2 and 3. 6 is present here, 6 is present here, and 6 is present here also. 6 is dividing both the numbers fully, because all the factors which are present in 6 are also present in the other numbers, okay, with whom we are dividing with 6. But in this scenario, if I am taking 12, 12 has one more 3 which is not present in 42, so it is not dividing it fully. Okay, so I hope this is clear. What we have done, we have written the prime factors of both the numbers, and if we have to see that one number is the multiple of another number, then they should have common factors. Okay, now what we have is, we have figured it out of this exercise. Are the following pairs of number co-prime? Guess first and then use prime factorization to verify your answer. So answer 1, again I'm taking here two parts. I'm taking A and C. A and C will do, these two are homework. So first of all, we have 30. What we will do? We will write down the prime factorization of 30, which is 6 into 5 will give us 30, right? Now I will break this 6 furthermore, 2 into 3 into 5, right? So for 30, these are the factors. Now I want for 45. For 45, we have 5 into 9, right? And I can write 9 as 3 and 3, right? So if I see here that guess first and use the prime factorization to verify your answer, we have to find if they are co-prime or not. We have two here, we don't have 2 here. We have 3 and 5 here, we have 3 and 5 here also. So since we have 3 and 5 common in both the numbers, okay, so that means they are not co-prime. They are not co-prime because they have 3 and 5 common. Next, I'll take C. So for C, we have 121, which has 11. And next we have 1331, which is 11 and 11 and 11. So we have this 11 common. That means these are not co-prime. Why? Because we have 11 into 11, that is 121 common in them, right? 11 two times is common in them. So they are not co-prime. These two are easy, kids. This is homework for you. And now we will go to second question. So the first part of the second question here is the first number, this number, divisible by the second? We have to see using the prime factorization. So how we are going to do this? 225. I can write 225 as a factor of 3 multiplied by 75. And then I can further break this 75 as 3 and again 3 and 25. So these are the prime factors of 225. And then we have 27. For 27, and again I can break this as 3 into 3 into 25 as 5 into 5. These are the prime factors. Next we have 27. I can write 27 as 3 into 9, which I can further write it as 3 into 3 into 3. Now we have to compare these numbers and these numbers. So if I see here, we have 9 common in both, which is good. But this 3 is missing here. It is not present here. So that means 27 is not dividing 225 fully, completely. I should write completely. Okay. Next I'll take D part. Let's do D. I have taken A, I'll take D. So in D, what we have 999 and 99. So I can write here 999 as, wait, I'll just move it up. Yeah, I can write this as 3, 9 multiplied by 111. I can write this as 3 into 3 into 111, right? And now I can write down 99 as 3 into 3 into 11, right? So here also we have 3 and 3 common in both, but 11 is not here. 11 is missing here. Since 11 is missing here, that means 99 is not dividing 999 completely. Okay. Next. So what we have to do, we have to find the factors and then we have to see if it is present fully. So let me take B also, kids. Let's try and see what is there in B. Okay, let me see what are the numbers. They are 96 and 24. For B, we have 96 and 24. So 96, we have 3. I'll multiply by 32. And I can now break this 32 into 16 into 2. And 16 I can write as 4 times 2, right? This is 4 into 4 is 16 and then this 2. So these are the prime factors of 96. Moving to 24, we have, for this 24, we have 2 multiply by 12. So I can write this as 2. This 12 I can write as 2 into 2 into 3. So if I see, I have 3 2 here, I have 3 2 here, I have 1 3 here, I have 1 3 here. That means all the factors of 24, all the factors which are present in 24, 3 2s and 1 3, they are present in 96 as well. That means 24 is dividing 96 completely. Okay, so this is also done. What we have done, we have found out their factors and the factors by of the number which is dividing the other number. It should be present totally in the another number. If all the factors are present, that means the number is dividing, otherwise it is not. Now, the first number has prime factorization of 2 into 3 into 7 and the second number has prime factorization of 3 into 7 into 11. Are they co-prime? So since here, kids, we know that 3 and 7 are present in both, that means they are not co-prime, right? Because we have the two factors except one which are common. Does one of them divide the other? So if we see here, we do not have all the factors of one number completely present in the another. Here 2 is missing and here 11 is missing. So answer is no, because all the factors of one number is not present in the another number. One of them is missing. Next is Guna says any two prime numbers are co-prime. Is he right? So kids, here we have to find this out. We know that co-prime numbers, we cannot further break them. Okay, so that means they have nothing common in them except one. So that means this is true. Okay, if I take example of 5 and 7, so the factors are 1 and 5 for 5, and for 7 it is 1 and 7, so only one is common, right? So this statement is true. So now kids, we have done all the question of this figure it out also, and we are done with the prime factorization and all the questions related to it. And in the next exercise, in the next class, we are going to take the divisibility test. But before moving it to that topic, I want all you to practice co-prime numbers, factorization, prime factorization, this divisibility using prime factorization. It will be very easy for you to understand the rest of the chapter based on, because it is based on this. Okay, so we'll see you all in the next class now.